Hi everyone, this lesson is for geometry students. This is the day 2 of our final exam review for first semester. So let's get started. The first question on in your packet that we're going to review is the measure of an angle is 3 times the measure of its supplement. So when you're thinking of an angle that has a supplement, you should be thinking of a straight line and then 2 angles that add up to be 180 degrees. Now, regardless, if you don't know what the angles are, like let's just say I said this was 20 degrees, right? Well, then this angle would be whatever 180 minus that angle was, like 180 minus 20, right? Which would be 160. So you need to know what this angle is. If you don't know what that angle is, then you can call it, I don't know. So let's call it, I don't know what that angle is, but this angle, which is the supplement, is going to be 180 degrees minus whatever that angle is, which we don't know, which we're going to find out. The measure of an angle, so that's my x. So the measure of an angle is means equals, 3 times the measure of the supplement. The supplement is 180 minus x. And so you're going to distribute and you're going to solve for x. And then we're going to find the measure of the angles. So we go x is equal to 3 times 180, 540. And then 3 times negative x is negative 3x. I'm going to take that 3x, I'm going to move it to the other side. So I'm going to add 3x to both sides. So on the left, I get 4x is equal to 540. And so I'm just going to take 540 and I'm going to divide that by 4. And I get 135. So x is equal to 135 degrees. So my angle is 135 degrees. So that means, and obviously it's not drawn this scale, but if this is 135 degrees, then this angle over here is 180. So 180 minus 135, which is just 45, right? Not drawn to scale. Totally fine. All right, for this value here, what we're looking at on this problem here is, remember, vertical angles. So we know that vertical angles, those bow tie angles that make the x, right? Those values are equal. So we know that 3y plus 10. So 3y plus 10 does equal 2y plus 20. So we're going to subtract 2y from both sides. I get y. I'm going to subtract 10 from both sides, and I get y is equal to 10. Check. So we know what y is. We also should know what the angle is, by the way. So I know that y is equal to 10. If I were to plug this value back in, right? So let's say 2 times 10, and it doesn't matter which side, because they're equal, remember? Vertical angles are equal. So 2 times 10 is 20. 20 plus 20 is 40. So that means this angle is 40 and that angle is 40, which means that this being a straight line, supplementary, those two angles, this is 40. 180 minus 40 is going to be 140. So we know that x is equal to 140 degrees. And we also know that y is equal to 10. And, I do prefer solution sets, especially when we're solving. But because this is an angle measurement, I'm okay just putting, boxing it up or just saying 140 degrees. Y, though, is not a degree. Y is a number. Find the value of x. And given that ABC, okay, so we have, looks like I'm missing my picture. Hold on 1 second. Looks like we're missing the picture here. So let me get that real quick. All right. So find the value of x if the measure of angle ABC, so that whole angle right here, ABC, so this whole angle right here is equal to 6x. Angle 1 is 2x plus 5, and angle 2 is 3x minus 1. So basically what we know is that the whole length is 6x. And then we've got the two little parts that add up to be the whole. We call that the angle addition postulate. That's what that's called. And so what that means is that 3x minus 1 plus this angle, this little angle here, plus this little angle here, which is 2x plus 5, is equal to the big angle, which is 6 times x. We're going to add these up. So 3 plus 2, that's what, 5x. And then negative 1 plus 5 is 4. Is equal to 6x. We're going to subtract 5. I get x is equal to 4. Find the value of x. We did it. Okay, so that's it. I would assume, though, that on the test, you would actually have to plug these values in, because they may say, hey, find the measure of angle 1. If they said, find the measure of angle 1, I would take this 4 and plug it into the x. So 2 times 4 plus 5. So that would be 8 plus 5. All right, so you would have the measure of an angle. You should be able to plug those values back in to find their answers if you need to. For this problem here, it's asking me to find the value of y. Well, we know that from here all the way around 180 degrees. So we just have to add these up and set it equal to 180 degrees. So we have 2y. So basically you're going 2y plus 3y plus 20, and then adding y plus 10. And all of that adds up to 180. So we have 2, 3, 4, 5, 6 y's. So we have 6 y's, 20 plus 10, which makes 30. And that equals 180. I'm going to subtract 30 from both sides. So if I subtract 30 from both sides, I get 6y is equal to 150. 150. And if I divide by 150 divided by 6, I get a quarter, or just y equals 25. And that's y. And what is it? They only want to know y. I would ask you, though, for me, I would ask you to find all the angles on the in there. Find the value of x if the measure of angle 1 is 4x minus 3 and the measure of angle 2 is x plus 8. So again, we know that these two angles obviously add up to be 90 degrees because they're complementary. See the right angle there? So we would say 4x minus 3 plus x plus 8 equals 90 degrees. 4x plus 1x is 5x. Negative 3 plus 8 is 5. And that equals 90. I'm going to subtract 5. I get 5x is equal to 85. And then I'm going to take 85 and I'm going to divide by 5. And I get 17. I believe. Yep, 17. Okay, so that's my answer. Now again, what's angle 2? So like I might ask you on the test, what's the measure of angle 2? Well, I'd have to put 17, right? 17 add 8, and that would be 25. So the measure of angle 2 would be 25 degrees. Now, if I know, right, that that's already complementary, and I know that that angle is 25 degrees, 25, then all I would have to do is go 90 minus 25, and that would be 65. So I already know what the other angle is. But I could plug 17 into x right here. 4 times 17 minus 3 is still going to give you also 65. For this problem here, it's telling me that L is parallel to, they're both parallel, L and L. And our job is to find angle 1, which is over here. Okay, there's angle 1. Well, but in the meantime, we know that if these are parallel, then we have same side interior angles, right? Same side interior angles are supplementary. What that means is that 5x, see these two inside, this one and this one, they add up to be 180. They're on the same side. They're called same side interior angles. They're supplementary. 5x plus 16 plus 3x plus 20 is going to add up to be 180 degrees. Okay, so let's see. X, 3, and 5. So that's 8 x's. And then 16 plus 20 is 36. That adds up to be 180. So I'm going to go 180 minus 36 is 144. So we have 8x is equal to 144. And then I'm going to divide by 8. So x is then equal to 18. So we found x, which is not the angle, and it's not my answer, right? But I do remember that angle 1 and 5x plus 16 are what we call vertical angles, right? Which means that they're congruent. So I can say 5x plus 16 is the same value as angle 1. But what I want to know is what's that value, because that's going to equal the measure of angle 1. I need to plug in 18 in here. So 5 times 18 add 16 is going to be the measure of angle 1. So 5 times 18 is 90. And then 90 plus 16 is just 106. 90 plus 16 is 106. And 160 degrees, that's this value right here, is what the measure of angle 1 is. Done. On this problem, now this whole chapter was about parallel lines. Parallel lines, super cool, super fun. All different kinds of things go on with parallel lines. Mostly, though, they're telling me that angle 2 is 40 degrees, by the way. That's this angle right here. But before we get to that, and that's just right here in the directions, before we get to that, I want to name the corresponding angles, all of them. And so you've got several. So let's see. Corresponding angles are angles that are on the same side, but both either on top, they're corresponding, or they're on the bottom. So like 1 and 5. So you would say angle 1 and angle 5. So let's go with and. So we're going to say angle 1 and angle 5. Those are corresponding. And then another corresponding would be 3 and 7. So you would say angle 3 and angle 7. Okay? So I'm going to erase these. And now I'm going to get to the other side to find the other corresponding. So angle 2 and angle 6 also corresponding. And remember, corresponding angles are congruent. So angle 2 and angle 6 are congruent. And then lastly, we would know that angle 4 and angle 8. So angle 4 and angle 8 are congruent. So those are corresponding angles. Corresponding angles are congruent. Okay? So there's that. And let me move that all in there a little bit. Okay. So corresponding angles, check. Done. Now let's do alternate interior angles. So alternate interior angles are angles that are on the interior of the parallel lines. So for example, this is my parallel line with this, right? So what's interior to that? That's what I'm looking for. So the angles that are interior are 3, 4, 5, and 6. But when they say alternate, that's every other, like that, right? So you would say that angle 3 and then alternate, that's where that comes from, is angle 6. So you would say angle 3 and angle 6 are congruent because they're alternate interior angles. And then you would also say angle 4 is congruent to angle 5. And those are also, this angle here, congruent to that angle there. Those are interior. Similarly, right? Similarly, if I wanted to find, oh, they didn't even ask that on here. The alternate exterior angles would be angle 2 and angle 7. Had they asked me, they didn't. And then angle 1 would be congruent to angle 8. Okay, they're exterior, etc. Okay, so moving on. Name the same side interior angles. Now, these are not congruent. Not congruent. These are just on the same side, which means they're supplementary. So you would say angle 4 and angle 6 add up to be 180. So let me just put that on there so you have that. Add up to be, yeah, I'll add those. Okay. So we'll say angle 4 plus angle 6 adds up to be 180. And angle 3 plus angle 5, these two, add up to be 180 degrees. All right. Those are same side interior. Now state all the vertical angles. I mean, that's just everything, right? 1 is congruent to 2. So angle 1 is congruent to angle 2. Let's see. No, that's not right. Hold on. Let me fix that. Hold on. Stop the presses. 1 is congruent to 4. So angle 1 is congruent to angle 4. Angle 2 is congruent to angle 3. Then we have angle 5 is congruent to angle 8. And then we have angle 6 congruent to angle 7. There. Those are all the vertical angles. They make the bow ties. All right. Lastly, they're saying, hey, this is 40 degrees right here. Let's put in everything we know. We know that's 40. That's 40 vertical angles. Alternate interior angles, 40. Also, this one and this one, corresponding angles. 40 there, and then 40 there. So then let's figure out what's the rest. Well, this makes 180 degrees, right? So that would mean 8 is 140, 5 is 140, 4 is 140, and 1 is 140. Done. Excuse me. Given A and B are supplementary, that means they add up to be 180 degrees. So let's draw that picture. Here's A, here's B. The measure of angle A is 2n. And the angle B is 3n plus 20. Now we know that if these angles are supplementary, then they're going to add up to be 180 degrees. So 2n plus 3n add 20 is going to equal 180 degrees. So 5n plus 20 is equal to 180. 5n is equal to 160. And then all you have to do is find out what's 160 divided by 5, and then n is equal to 32. And it's a solution. Put your answers in solution sets. Oh, we just found n, which is a solution. However, that's not my answer. Read the question. The question says, find angle B. Well, this is angle B. I got to plug this value in. So we're going to go 3 times 32, add 20. So we're going to go 32 times 3 equals, what is that? 96, add 20. I get 116. So this is how you write it. You're going to go, the measure of angle, capital B, angles are capital, sides are little. The measure of angle but B equals 116 degrees. And then we're done. Okay. What is the sum of the measures of the interior angles of a regular hexagon? Well, okay, so there's a formula, yes. And also, besides there being a formula, there's also, another way to figure that out. For example, right? For example, how many triangles do we have here? Let's see, we got one triangle, that would be 180, right? Another 180, another 180, another 100, 1, 2, 3, 480. So what's 4 times 180? 720. So the sum of the measures, sum of the interior measures of the angles, we'll go with angles. Okay, my hand's not doing what I'm telling it to do. Angles is equal to 720 degrees. Okay, so that's one option. It's just to divide everything into triangles, since you know that the measure of a triangle is 180 degrees. Similarly, there's a formula. To find the sum of the interior angles, it's going to be 180 times the number of sides minus 2. That's it. So number of sides, we have six hexagon. 1, 2, 3, 4, 5, 6 sides. So you would go 6 minus 2. So 6 minus 2, which is 4. 4 times 180. That was our 4 triangles, right? Also 720 degrees. Cool. All right. By the way, I would ask you, especially come January, we're going to be asking you to figure out the angle, one angle. So we would take 720 and divide it by 6, and you're going to get 120, right? But if each of these angles, if this is a regular, see how it says regular, polygon, hexagon, then all of these angles are all the same. Likewise, all the sides are equal. That's why they call it a regular, because all the sides and all the angles are the same. But think about the things that we can actually do. Like, for example, if I bring this down here, we actually call that an apothem, or some people call it an apothegm, but that's okay. And then we can cut that 120 degrees in half, and then that makes that a 60. Well, look at that, 30, 60, 90 right triangle, all sorts of super fun stuff that we can do with that, right? I know you're excited about that. All right, MATH is a parallelogram. AT is, I don't know if you can see that, but let me try to make that bigger. AT is x plus 6. So let's write that in, AT. So what we have, there we go, AT is x plus 6. TH is 2x plus 4. And HM is 3x. And it says find MA. Well, this is MA. All right, so here's the thing. They want this length here. Let's not call it x. that just brings in another problem. Don't call that x. Let's call that question mark, okay? Well, if this is a parallelogram, what are the qualities that you remember about a parallelogram? Well, what you should remember is that both pairs of opposite sides are congruent. So that side is congruent to that side. This side is congruent to that side. They're not all congruent. They're not all equal, right? So what you know is whatever this is, that is. But I don't have that value, right? So what I need to do is I need to use what I know. I know these two values here. I know that because it is a parallelogram, opposite sides are congruent. So I can go 3x is equal to x plus 6. Subtract x, I get 2x equals 6. I get x equals 3. So I know x is 3. So I can plug that into this equation here. So 2 times 3, add 4. So 2 times 3 is 6. 6 plus 4 is 10. And so I know that this length is 10, which means, question mark, is also 10. So you would say MA is equal to 10. And when you're doing that, just keep in mind that you don't put a line over, because it's a line segment. When you're talking about a measurement, you don't put a line over the letters. Okay? So next question. It says okay, hold on. It says given A is parallel to B. So here's A, here's B. A is parallel to B. T is perpendicular. So this was what? A, this is B. And it said T is perpendicular to A. Well, if that's going to happen, then guess what else is going to happen? This is going to be perpendicular. To use an indirect proof in order to prove that T, this is T, is also perpendicular to B, your first sentence is. So this is happening every single time. If you ever see the words, prove this as an indirect proof. The first thing that you're going to say is this, and like you're going to write it out. This is actually what you're going to say. Assume temporarily, yes, you need to use those words. Assume temporarily that whatever you're trying to prove is not true. So what we're trying to prove is that T is perpendicular to B, right? So that means we are going to assume temporarily that T is not perpendicular to B. You're assuming temporarily, and you can write it like this. Look, this is like way better way to write this. No, T is not perpendicular to B. So you have to assume temporarily that T is not perpendicular to B. That's what you say. That's like the question that you're going to be asked on your SATs. That's it. Every time. So it's like, if I want to prove that somebody has the license to drive a car, I would say, assume temporarily that X person does not have a license to drive the car. You always say, assume temporarily. If I want to prove that this is a square, I would then say, assume temporarily that this is not a square. That's what you say every time. Which of the following could not be the lengths of the sides of a triangle? Oh, well, what you need to remember for this problem is that for a triangle to exist, you have to have the sum of two sides has to be greater than the third side, period. So I like to make like a little triangle. Here we got 1, 3, and 2. And not just twice. Like, look, 1 plus 3 is 4. Is 4 greater than 2? Yes. And so therefore, is it a triangle? No, you have to go all the way around. So yes, 1 plus 3 is greater than 2. Check. But 3 plus 2, is that greater than 1? Yes. What about 2 plus 1? That's 3. Is 3 greater than 3? No. It has to be greater than. Not equal to, greater than. So this would be no. That's not a triangle. And realistically, if you were actually drawing this is what it would look like. Something like that. You'd have 1 is this little arm here, and then you have 2 is here, and they're not meeting, okay? So for this one, I'm going to draw another little triangle. I got 1.5, 4, and 3. It is not required that you draw a triangle. It just helps me see what I'm trying to see. 1.5 plus 4 is 5 definitely greater than 3. Check. 4 plus 3 is 7. 7 is greater than 1.5. Yes. 3 plus 1.5 is 4.5, greater than the third side. So this would be yes. This one here, that's going to be yes. Anytime you have an equilateral triangle, right, it's always going to be a triangle. So we have 4, 4, and 4. 4 plus 4 is 8. 8's greater than 4. You can do that all the way around. You can do that yourself if you want all the way around. But, once you add 4 plus 4, you're done. On the other one, you've got 2, 3, and 2. 3 plus 2 is 5. 5's greater than 2. Check. 2 plus 2 is 4. 4 is greater than 3. Yep. 2, and then we're done. So this is also a yes. So yes, and then yes. The only one that wasn't was that one. For this problem here, it says the larger of two complementary angles. Okay, so again, this was like the supplementary angle problem. So we're going to start off with a right angle. Here's my right angle. And I see two angles, so I'm just going to put a line in the middle. Okay, this is my template. That's how I'm starting. It says one of my angles, by the way, is x, right? All right. The other angle has to add up to be 90 with this x. So this would be the supplement, or the complement, which is 90 minus x, right? 90 minus whatever this is. For example, If this was 50, then this would be 90 minus 50, which would be 40. So that's how you write that complement. All right, so here we go. The larger of two complementary angles is 5 times the smaller. So the larger of two complementary, so I'm going to assume 5 times, we don't know what it is, 5 times x is equal 5 times the smaller, so 90 minus x. Let's see what we get. 5x is equal to 5 times 9, that's what, 450 minus 5x. I'm going to add x to the other side, and I'm going to get 10x. And then 10x is equal to 450. So that means if I divide by 10, I get x is equal to 45. One of them's x, which is 45. The other angle is 90 minus 45, which is also 45 angle. This is such a trick question. So what that means is that there's not a larger angle. They're both equal. They're both congruent because they're both 45 degrees. Okay. In this problem here, it says a triangle XYZ. So here we go. We have X, we have Y, we have Z. Just label them. And the measure of angle X is equal to the measure of angle Y. Ooh. So we're going to put that's congruent to that because they're equal. XY, where's XY? XY, that's a length of a side. Do you see that? The length of the side is 5x minus 5. That's this one. XZ, that's this side, is 4x plus 1. That's this one. And then YZ, that's down here, is 6x minus 7. Okay. Well, find XY. XY is over here. They want this, they want that. They want this length here. What are we going to do? Let's just like highlight it or something. Put a happy sign here. Okay, happy face there. All right, so they want this length here. But, okay, why did they give me 3 sides? Okay, they gave me 3 sides because, first of all, I'm going to have to find this side. Second of all, if I have 2 angles that are congruent, right? The angles are congruent. That means that the opposite sides are also congruent. So you have to know that if this is an angle here, see how these are the arms that make that angle? This side is going to be congruent to this side that's opposite. See, these are opposite. They are congruent. If the angles are congruent, the sides are congruent. Isosceles Triangle Theorem. That's it. So that means that 4x plus 1 is equal to 6x minus 7. So I'm going to subtract 4x, I get 2x. I'm going to add 7, I get 8. I get x is equal to 4, so x is equal to 4. But that's not the answer. That's my solution, not my answer. Find xy. This is xy. That means that I'm going to take 5x minus 5, and then I'm going to plug my 4 into the x. So we're going to go 5 times 4, 20, minus 5, 15. So that I know that, so this is how I would write it. Therefore, see that? That means therefore. 3 dots, therefore. xy, this is the lengths of a side. So by the way, these are capital letters. So let's try it. Capital XY is equal to, what did I say? 20 minus 5, so that's 15. And then box that up. Okay? This problem here, zoid is a trapezoid. Find MN. MN is this length in the middle. What you should remember about a trapezoid is that the median, which is this length right here that connects the 2 midpoints, that's half as long as the sum of the bases. Okay, so that means this, what it means. For the median, so MN is equal to half the lengths of the bases. So ZO plus DI. That's what it means. So MN, which is 3x minus 3, is equal to 1/2 of ZO, x plus 2. So x plus 2 plus 4x minus 2. All right, that's it. So we would then, let's see, 2's are going to cancel. Awesome. 4 plus 1 is 5. So we have 5 x's, and half of that, that's over 2, is equal, oh, you know what? I'm not gonna distribute that. That's a bad choice. Because, I mean, who wants to deal with fractions right now? This is going to be 5x, half of 5x is equal to 3x minus 3. I'm actually going to multiply by 2 to get rid of this fraction, okay? It's going to make me happy. So multiply by 2 on both sides. It is an equation. 2's cancel. I get 5x is equal to, and then now I just need to distribute. 2 times 3 is what? 6. X minus 6 is equal to 5x. I just have to move everything over to each side, okay? Move everything over. I'm going to move this down a little bit so I can finish my problem. Subtract 5x, I get x. Add 6 to both sides, I get equals 6. X equals 6. What do they want to know? They want to know mn. Because x is 6 is my answer, is my solution. That's not my answer. So I'm going to take this value and I'm going to plug it into mn because that's what they want, mn. So that means that mn is equal to 3x minus 3, right? X is 6. So 3 times 6, which is 18. 18 minus 3 is 15. So therefore, mn is equal to 15. Cool. All right. Triangle MNO. So we are going to make a triangle. So MNO. All right. MNO. So angle M is 3x. All right. Angle N is 4x add 8. And angle O is x plus 40. Oh, so what we know is that what we can do is we know that the sum of all of our angles adds up to be 180. So let's do that. So 3x plus 4x plus 8 plus x plus 40 is equal to 180. All right. So let's count our x's. All right. So we've got 3 plus 4 is 7 plus 1 is 8. So we've got, plus 1 is 8. 8 x's. 8 plus 40 is 48. And so therefore that equals 180. All right. So I'm going to take 180, subtract 48. And what do I get? 132. So I get 8x is equal to 132. And that means I'm going to divide by 8. And I get 16.5. So let's plug this value. I think what we need to do is we need to plug these values in. Let me make sure I did this right. 3x, we've got 4x plus 8. We've got x plus 40. So 1, 4, 5, 6, 7, 8 x's. We've got 8 plus 40. Okay. All right. So x is equal to 16.5. I'm going to plug everything in. So 3 times 16.5, that's 49.5. So this angle, so let me do another angle, triangle. So this triangle, this angle is 49.5. So then I'm going to go 4 times 16.5. I'm over here. And that's 66. And then I'm going to add 88, and I get 154. Ooh. Uh-oh. What's the name of this triangle? Does it exist? Let's see. 4 times 16. Let me do this again. 16.5 times, let's see, 16.5 times 4 is 66. 66 plus 8 is 74. Hello. I can add. Okay, so this is 74. And this right here is 74. And then therefore, this angle here is 40. Let's see, 40 plus 16.5, and that's 56.5. Okay, so what it looks like to me is that none of these are congruent, which means that what's the best name for MNO, the triangle? It's a scalene triangle. S-C-A-L-E-N-E, scalene, because none of these angles are congruent, which means all the sides don't equal. So that is not equal to that, which is not equal to that. That's what that means. Find the value of x. It's the right triangle. I'm missing one side. I'm going to use Pythagorean Theorem. And so the biggest issue, I think, with this problem, 2 root 6 quantity squared plus 5 squared is equal to x squared. The biggest issue is that a lot of kids mess up on 2 root 6 quantity squared. All that means is 2 root 6 times itself. That's what that means. All right. So you're going to multiply numbers with numbers. So the 2 times 2 is 4. Root 6 times root 6 is 6. You know, it's root 6, 36, but the square root of 36 is 6. So we have 4 times 6, which is 24. So we have 24 plus 25 here, which is what? 49 is equal to x squared. So x is equal to, now, we talked about this in classes. The answer is 7. But what we talked about in class was that the difference between the square root of 49 and the difference between that and x squared equals 49. And what the difference is basically is that this is quadratic, which means I get two solutions. And when I take the square root of both sides, normally I would get plus or minus 7. But because we're talking about an actual length, right, there's no negatives in the length. So we negatives out. And the square root of 49 is just 7. All right, so if it's an equation, you get two answers, right? If it's not, you don't. Okay, anyway, we talked about that a little bit. All right, don't forget that. Okay, so for this problem here, what are we trying to find? X, but there's no X here. So let's put one in there. I'm just going to put it here. Okay, let's find, this looks like an equilateral triangle, which means this is 60 degrees. So two ways you could do this, right? If you remember your 30, 60, 90s, across from the 30 is A, which is 2. Across from the 90 is 2A, which is 4. And that means across from the 60 is A, which is 2, root 3. So 2 root 3 is equal to my X. However, we're going to cover a lot of special right triangles in January, so forget that. And let's just use Pythagorean Theorem, right? So we are going to go x squared plus 2 squared is equal to 4 squared. So we have x squared plus 4 is equal to 16. So x squared is equal to, what, 12? And then x is equal to the square root of 12. Now remember, you can break that down. That's going to be root 4 times root 3, which is equal to 2 root 3. So that's what x is. Cool. And by the way, see up here, if you knew your special right triangles, you would be done. All right. 45, 45, 90 triangles. Same thing. Same thing. 6, 6, 6 root 2. Done. This is another special right triangle. However, if you forgot that this is a 45, 45, 90 and how to do this, or you just never learned, what you would then do is you would need to remember that, hey, if this is 90 and that's 45, right? 45, 45 makes 90. These have to be equal, which also means that these are congruent, right? Same value. So you would go 6 squared plus 6 squared, and what you're trying to do is find x, right, is equal to x squared. 36 plus 36 is equal to x squared. Well, that 72 is equal to x squared. So x is equal to the square root of 72. Now, remember that the square root of 72 is actually root 36 times root 2, right? So that means that root 36 is 6 times root 2, 6 root 2, and that's it, equal to x. And guess what? We're done. And look, special right triangles. This is exciting to look forward, something to look forward to, right? Okay, for this problem here, it says find the length of the diagonal of a square that has a diagonal length of 10. So we know that. We don't know this side. Oh, but we don't know this side either, right? So, but because it's a square, they told us that. We know that both of the sides are congruent. All the sides, all the way around. But we know that. So then we can say, well, x squared plus x squared is equal to 10 squared. So now I have 2x squareds is equal to 100. Divide by 2, I get x squared is equal to 50. Square root both sides, right? And I get x is equal to, let's break that down, to 25, root 25 times root 2. Square root of 25 is 5. So that means my answer, 5 root 2. And that's x, okay? Kelly took a shortcut by walking along a diagonal of a 30 by 16 rectangular field. Okay, let's draw that. All right, here we go. And let's see. Let's put Kelly in here. Kelly, there you are. All right, a diagonal of a 30 by 16. So let's go. That's 30. That's 16. It's a rectangle. So these are right angles. How much farther did she have to walk if she had walked along the edges of the field? So, I guess you're trying to get to this point right here. All right. And in order to get to that point, we got to go either diagonal, which is what I believe Kelly did. Let's use K for Kelly. Okay. So here's K. And then, or, right, we would go down and over. So that's obviously what, 46? We'll call that feet, meters. So 46 meters. If Kelly took off and went 16 this way, 30 this way, 46 meters. All right, but hopefully we can get less than that. So let's see. let's try to find out what that diagonal shortcut is. So we're going to go 16 squared plus 30 squared is equal to k squared. 16 squared, 256, right? 256 plus 30 squared is 900. So I'm going to use my calculator. 900 add 256. I get like 1156. 1156 equals k squared. So that means k, Kelly, we're going to take the square root of both sides, right? And square root of 1156 is 34. Cool. Exactly 34. So that means this is 34. 34. Okay, so this is 34, which then means, by the way, if she had walked along, okay, so how much farther is that? So I would just go 46 minus 34, 2, 1, 12. 12 meters. She would have had to walk an extra 12 meters. All right. It's not the end of the world. What you need to know here is it says, oh, this is the exterior angle theorem. Yeah. So what that means is this one exterior angle, this angle here, is equal to the sum of the two remote interior angles. Remote meaning away from. So it wouldn't include this angle. All right, so that means that this one angle, 8x plus 12, is equal to the sum of those two. So we would go 7x plus 22 and then add 5x minus 54. Okay, what do we get? We get 8x add 12 is equal to 7 and 5. So we've got what? 12x, 22 minus 54. That's a negative 32, minus 32. So what I'm going to do is I'm going to subtract 8x and I'm going to get 4x, right? I'm going to add 32 and then I'm going to get this equals 44. So that means x equals 11. What do they want to know? Okay, you've got to be careful and you've got to make sure you're answering the question. This says x is 11. Well, okay, we found x, but is that the answer to the question? No. The answer to the question is they're saying what's angle B? B is 7x plus 22. So part 2 is 7 times x, which is 11, add 22. So we're going to go 77 plus 22 is 99. So that means angle B, so this is how I would write it. The measure of angle capital B is equal to 99 degrees. And then I would box that up. Okay? All right. The lengths of the sides of two triangles are 12 and 16. All right. What's the length of the third? Oh, what could the third side be? Okay, there's like a little formula for this. Okay, x. Here you go. It's less than that value and it's greater than that value. So on the left side, you go, well, it's greater than whatever 12 plus 16 is. Oops, that goes on the other side. Hold on. Boom. And then on this side, it's 16 minus 12. So 16 minus 12 is 4. Less than, so x is greater than 4, but 28, less than 28. Because remember, the sum of the two sides of a triangle have to be greater than, but not equal to the third side for a triangle to actually exist. So there you go. You just add the two sides. One you add, one you subtract. Okay. For this problem here, you have to tell whether the triangle is acute, right, or obtuse. So yeah, we have been doing these problems, so just make sure you do know how to do this. Just to review again, a squared plus b squared, if the sum of the two sides is equal to c squared, the triangle is a right triangle. If a squared plus b squared is greater than the third side squared, that is acute triangle. And if a squared plus b squared is less than c squared, then this is obtuse. Okay? And so that's what we're looking for. All right? So here we go. A squared and b, these are my first two sides. So you're going to take the first two sides and square both of those. So 2 squared is 4. Square root of 5 squared is 5. So 4 plus 5 is 9. How does that compare to the third side? 16 squared, c squared. Well, this is bigger like that. See this one? That means that these three numbers, that triangle is obtuse. This one's a right triangle. You should be able to see that this is a triplet, right? What are the triplets? 3, 4, 5. 5, 12, 13, 7, 24, 25, and 8, 15, and 17. These are the triples. And so obviously 8, 15, 17 is a right triangle. I don't have to do that. But if you wanted to, you would go 64 plus 225 is equal to, what is that, 343? Okay, for this problem, 6, 8, 15. Okay, so yeah, 6 squared plus 8 squared. Let's see, that's 64 plus 36. 64 plus 36, 0, 1, 6, 7, 8, 9, 10. Okay, so that's 100. And how does that compare to 15 squared, right, which is 225? So 15 squared, so which one? Okay, so we know that this is less than 225, which means, oh, this is obtuse again. Okay, cool. And then this one is 0.7 squared plus 0.8 squared. So let's see, 0.7 squared plus 0.8 squared is 1.13. And then 0.19 squared is 0.81, which means that this is bigger, which means that it's an acute triangle. All right. For this problem here, XYZ is an acute triangle. Oh, is XYZ an acute triangle, a right triangle, an obtuse triangle? Oh, this is another problem just like that. So I'm just going to label it. We have X, we have Y, we have Z. We know that XY is 20, YZ is 21, and XZ is 29. So this is my biggest side. So the sum of these two sides, the squares, so have to be, what is it? So we're going to go 20 squared plus 21 squared. So we know that this is 400 plus 21 squared, which is what, 441? So plus 441, which is 841. How does 841 compare to 29 squared, which is, 841? What is it? So what you need to know is that if these are equal, it's a right triangle. Okay. All right. These ones right here are asking me to find the area. Okay. So this is a square. I have two consecutive sides that are congruent. It has to be a square. It's or a rhombus, but this is a right triangle, so it cannot be a rhombus. So that's just 1.2 times 1.2. So 1.2 times 1.2, which is 1.2 squared. So 1.2 squared, and that's 1.44. 12 times 12, yeah, 1.44. And then whatever, I'm just going to call these units, and that's units squared. For this problem here, find the area of each figure. So this is a rectangle, and the way you find a rectangle is length times width, base times height. So we already know it's 8 times this value here, but I don't have that value because I don't have it. So I'm going to use the right triangle. I'm going to use Pythagorean Theorem first. So we're going to go 8 squared plus, we don't know what that side is, we'll call it x squared, is equal to 12 squared. So x squared is equal to 144 minus 64. 144 minus 64 is 80. So x is equal to the square root of 80. And then, well, what's the square root of 80? Let's break that down. I'm going to use, divide that, right? Divide that by 4, you get 20. Another 4, so I would take 80 and divide that by 16, I think. So 80 divided by, what, 16 is 5. So then we know that this is 16 times 5. And so what that means is that this is x is equal to 4 root 5. All right, well, now that we found that side, okay, we have x. All right, so we know x is 4 root 5. All right, so now I can find the area. Yeah, you got to remember what you're trying to find. So the area is the length times the width. So that's going to be 8 times 4 root 5. Numbers get multiplied with numbers. So the area is going to be 32 root 5, and then this is just units squared. Okay, box that up. For this problem here, this looks like it's a rhombus. And a rhombus, in order to find the area of a rhombus, okay, so I'm not sure if all the classes actually did this. Maybe. So let's just go over what a rhombus area is. So that's going to be 1/2. The area of a rhombus is 1/2 diagonal 1 times diagonal 2. All right, so the area, so we have the first diagonal. So the area is equal to 1/2 the first diagonal, which is 10. But we need the second diagonal, okay? This is definitely not a right triangle. So what I'm going to need to do, I need more space. So what I'm going to do is this. I'm going to add another page here because I want more space. And, okay, there we go. And so what we just said, what I just said, was that the area of this rhombus, so the area of a rhombus is equal to 1/2 diagonal 1 times diagonal 2. So we have one diagonal, which is 10. All we need is to find the second diagonal. Okay, so now I'm going to put another value, another diagonal in here, right? What you need to know about a rhombus is that the diagonals are perpendicular. Best thing ever. So that's 5. And also, if it's a rhombus and you have two sides consecutive like that, see that congruent? All sides of a rhombus are congruent. So 13 all the way around. So that means that this is 5, this is 13. Oh, right? What's this side here? It's a 12 because remember the triplets, 5, 12, 13. Okay, but let's just say you forgot. You would go 5 squared plus x squared is equal to 13 squared. So 25 plus x squared equals 169. Subtract 169 minus 25, I get x squared equals 144. And the square root of 144 is 12, just like I said. So this right here is 12. No, this wait, hold on. Let's see, 5, 12, and that's 13. Which means that this side is 12 also. This whole length is 10, right? But this is 12 and that's 12. Okay, so 12 plus 12 is 24. So the second diagonal is 24. All right, so now we go, 2 divides into 24 12 times. 12 times 10 is 120 units squared. So that's the area of my rhombus. See, I told you I need more space. Okay. More area problems. This looks like an equilateral triangle, and I have a perimeter of 42. So we're going to take 42, and we're going to divide that by 3, right? 42 divided by 3 gives me 14. So that means each of my sides is 14. It also means this, that if I were to draw in an altitude in an equilateral or an isosceles triangle, that altitude is going to cut that base in half, meaning that's 7 and that's 7. The area of a triangle is equal to 1/2 base times height, but you do need to remember that the base has to be perpendicular to the height. You just can't pick any number to be the height. It's got to be perpendicular. So my base, which is not 7, right? My base is 14. So it'd be 1/2 the base, which is 14, times the height to find the area. So now we just need to find this height. So remember, this is a 30, 60, 90 right triangle. I know some of you are thinking that you can just use that, which you totally can. But those of you who didn't learn that, so this is also 14. When I bring this down, this is 7. What I'm saying is this is 60, right? That's 30. Could I use tangent? Absolutely. Do I need to? No. Because I know that's 7 and I know that's 14, I can use Pythagorean Theorem to find this third side, okay? So I'm going to go x squared plus 7 squared is equal to 14 squared. So x squared is equal to 14 squared, which is 196 minus 49. 196 minus 49 is 147. So the square root of, square root of 147 is about 12. I'm just going to say it's about 12. So there's 12. So x is about 12. That's my height. So I'm going to put about 12 here. 2 divides into 14 7 times. And we're going to go 12 times 7, and that's just 84. So the area of that triangle is about 84 units squared. And yeah, we rounded to the nearest whole number. Okay, for this problem here, this looks like it's a trapezoid. And so therefore, if this is a trapezoid, the area of a trapezoid is going to be height divided by 2 times the sum of the bases. So it's going to be sum of the bases. So base 1 plus base 2. So that means my height is 9. So 9 divided by 2 times the sum of the bases, which is 20 plus 24. So all we have to do is add and multiply. So we got 20 plus 24 is 44. 2 divides into 44 22 times. And now I have 22 times 9. So 22 times 9 is 198. So the area of my trapezoid is equal to 198, and that's units squared. For this problem here, I want to find the area of all of these tiny little parts. Again, definitely misjudged the space. So let's put that here. And so when we're trying to find the area of this shape, what we're going to do is break it into parts. Well, actually, I was thinking about breaking it into parts, but now I'm looking at it and I'm thinking maybe I'm just going to find the area of the big rectangle and then subtract this little cutout. See that right there? Ooh, actually, I am allowed to change my mind. Actually, I'm going to subtract this and then this. Okay, so the big triangle. So this is my job. This is my idea. 16 times 16, right? So take the area of the big square. And it's a square because it's 16 times 16. Subtract this little square down here and then minus that little tiny square down there. So it looks like this is going to be 16 times 16, and then 16 times 16, 256, and then I'm going to take away this triangle, this little square here, and this is 8 times 4 and 4, that's 8, that's 64. So 256, I've got minus 64, and now I have to also subtract this little part here, which is 16. So now take that value, which is 192, and subtract 16, and I get 176. So the area of this shape is equal to 176 units squared. Now, yeah, I did this a different way than I thought I would do that, but just keep in mind, I could have like even broken this up into little pieces like that and found the area of all these little pieces. And then you could have done that. It was fine. 3 more problems and we are done. This is a trapezoid. Find the area of the trapezoid. Again, area is equal to the height divided by 2 times the sum of the bases. Okay, so the height, 9. So the area is equal to 9 divided by 2 times the sum of the bases. One of my bases is 7, but I don't have the other base. But what I do know, and this is always fun, right, is see this is 9, okay? And so if I were to take that value and just kind of slide it over there, there's 9. That's 9 also, right? We also know that's 7. So what's this length? That's all we got to do is find that length right here, and then I can, add it to 7. So we're going to go x squared plus 9 squared is equal to 15 squared. 15 squared is 225. So we're going to go 225 minus 9 squared, which is 81. And I get 144. So x squared is equal to 144. X is 12. So this little value down here is 12. And so 12 plus 7, because that's my base, right? That's the base, the bottom base. Base 1 plus base 2 is going to be 19. Okay, so then we just add, what's 19? Add 7, I get 26. So this value is 26, and that's times 9 over 2. 2 divides into 26 13 times. We have 13 times 9. So the area is 117 units squared. Okay, isosceles triangle. This right here breaks down again. Remember, 4 and 4. So this little length is 4. I'm going to find the height so that I can use 1/2 base times height. So I'm going to go x squared. This is a 4. X squared plus 4 squared is equal to 10 squared. So we go x squared is equal to 100 minus 16 is 84. And then I'm going to take the square root of both sides. So I'm going to do an approximate, not exact answer. So 84 square root, that means I can have a decimal. So x is about 9.2. So that means my height right here is about 9.2. So 9.2 9.2. So to find the area of my triangle, okay, the area of my triangle, I'm going to go 1/2 the base times height, but remember, the base has to be perpendicular to the height. So we're going to go, the area is equal to 1/2 my base, which is 8, not 4, 8, times the height, which is 9.2. So I'm going to go 1/2 of 8 is 4, and then I'm going to go 9.2 times 4, and that equals 36.8. So the area is about 36.8 units squared. Cool. All right, last one. This is a parallelogram. Parallelograms, both sides, opposite sides are congruent. So that's 7, that's 7, that's 5, that's 5. The area of a parallelogram is different because it's base times height. However, the base has to be perpendicular to the height. So you may be asking, hey, why did they give me 4? Or maybe you're asking, why did they give you 5? They did that because the base has to be perpendicular to the height. So when I'm finding the area of this parallelogram, my base is 7, but my height is 4 because my base has to be perpendicular with the height. And just because that 4 is out there, or, outside, you're like, wait, that doesn't count. See, you can drag that 4 in. It's still inside there. That height right here is the same height as it was outside. All right, so the area is going to be 7 times 4, which is 28 units squared. All right? So your job is to finish any part of day 2 review worksheet that you didn't finish. I wish you the best of luck on your final exam, and thanks for watching. I hope it helped you. Okay.